In this video, we will be demonstrating the vortex apparatus, the H13 from Techquipment, for demonstrating the phenomena of free and forced vortices, including the study of surface profiles, head variation, and comparison of experiment results with theory. In fluids, you might think of a whirlpool wake of a boat, or in the air in the form of tornadoes, or as air swirls as a passenger wing trails by. A whirlpool in a river and the flow down a plug hole in a sink are example of free vortices. There is an initial force that generates the spinning of the water, and then it slowly contracts and dissipates. Whereas a forced vortex is the spinning or swirling of water that is generated by external forces, like an impeller in a pump, or forced mixing in food processing machinery. With this apparatus, students are able to create fluid vortices and measure the surface profiles, and for the forced vortex in particular, you can also study the head variation. Let's take a closer look around the apparatus, which consists of a transparent cylindrical vessel on a support frame which mounts on Techquipment's hydraulic bench. The bench is a separate item. You can also mount it on another suitable clear water supply and drain. The adjustable feet at the bottom allow you to level the apparatus in the case of any uneven surface, like a sloped draining area. Fitted at the bottom of the frame, below the vessel in the base section, is a low voltage motor. This rotates the vessel at different speeds. Separate to the vessel is a speed control unit connected by this cable. Water enters the vessel through this pipe here, and at the bottom there is a waste pipe. There's a hole in the base of the vessel that leads to the waste pipe that can be closed by this plug. This is used in some experiments where you want to have a fixed amount of water within the vessel itself. The fundamental element of this experiment is about physically measuring the water, hence the array of measurement devices. Along the top of the vessel is a horizontal scale, then a pitot tube that is attached to the horizontal scale using the traversing head. Then we have both a traverse probe and pitot probe. Now it's time to have a go and show you what a forced vortex and free vortex looks like. To produce a forced vortex, first you ensure the center plug is in place. Then we get the vessel rotating slowly, increasing the speed up to about 60 revs per minute. At this point, slowly fill the vessel to about half full. With that done, we can up the speed steadily up to 100 revs per minute for the actual test. Now you can see the forced vortex formed. After a few minutes, the vortex becomes constant, and you can measure the surface profile using the traverse probe. This can be moved both horizontally and vertically, and both axes have linear scales. Students can also measure distribution of total head by replacing the traverse probe with a pitot tube. You want to be taking about 10 recordings to get a decent data set, as shown here. Now to produce a free vortex, first you remove the plug and put this small perforated transparent cylinder inside the main vessel. Now get the vessel spinning at 50 revs per minute and add water to the annular space around the cylinder. Carefully adjust the speed and you can create a steady vortex like this. You can now see that when the vessel rotates, water passes through the perforations and spirals slowly inwards to a small hole in the center of the base of the vessel. The surface falls rapidly towards the center and produces an air cone. Now you can measure the surface profile using the traverse probe. With all the data entered into the table, it's time to do some math and see how the findings match up to the theory. That's it on the vortex apparatus in this video. Techquipment also offers another experiment for examining vortex-induced vibrations, the FC300M, for use with the larger of Techquipment's flumes. This demonstrates that the drag force of water induces a suspended pendulum from alternate sides, a Kármán vortex street. For more information about the apparatus discussed here, click on the links below. Don't miss us next time by following this channel. Thank you for watching.